Assalamualaikum warahmatullahi wabarakatuh and hi everyone. First of all, I would like to introduce myself. My name is Muhammad Zakri Iezaac bin Muhammad Zaidin, the team leader of Group 1, which also known as Dirgahayu or Berhad. Other than that, I am also the lead of PetroPhysics and Facilities. Next, I would like to introduce my group members. First,
Aqilah Binti Rahman, and I lead the production technologies and HSE. I also support the G&G department and drilling department.
Hello, my name is Harith by Aimiros. For Dirgahayu or Berhad Field Development Project, I'm the leader for Reservoir and Drilling Engineering Department.
Hi, my name is Shuhadha Binti Muhammad Khairi. I lead the Geology and Geophysics and will be leading the Economics Department. Chapter 1, Geology and Geophysics. This chapter particularly involved in a lot of literature review which aim to evaluate the geological setting of our case study. This include petroleum system, well correlation, stratigraphic setting, as well as the development of the geological setting model by using Petra, and finally to come out with the volumetric estimation assessment. Move on to the workflow. So these are the steps that have been followed throughout the study, which firstly we did the literature review to identify the stratigraphic settings and the geological information of the our reservoir, which in the Sabah basins, and next to develop the two-dimensional cross imaging, and then move on to the well correlation by using the tag log. After that, we develop the 3D static model by using the Petrel, and lastly we calculate the GRV and STOIC.
For the introduction, Glamour Merah Field is located at Sabah, which is a state in Malaysia. It is located at Sabah Basin, which is one of the major areas for the potential of oil and gas reservoir, as the basin contains many faults and natural traps which accumulate hydrocarbon. The water depth for Glamour Merah Field is about 50 meters. This field is located in Block SB 1812 offshore Sabah, Malaysia. The age for this field is Middle Miocene, and the nearby producing field is Samarang Field. In dimensional cross imaging, we plotted two-dimensional views based on the structural map. The structural map is a map that contains a contour line which connects points of equal thickness to illustrate relief on a map. It portrays a stratigraphic thickness of a rock unit as opposed to the true vertical thickness. The number of contour lines on structure map represents the geometry of the reservoir to illustrate the difference in thickness within a layer or strata from top view. Hilly slopes are shown when the contour lines are close to each other, while gentler slopes are shown when the contour lines are apart from each other. The depth shown in the reservoir is between 1,300 meters until 1,800 meters, and the scale for this map is 1:250. The vertical and horizontal cross sections were plotted using Microsoft Excel, where the x-axis represents horizontal line and the y-axis represents the depth of each zone. From the well correlation and pressure plot graph, it can be seen that the possible all-water contact in Glamour Merah is at 1,480 meters. Next, for the exploration opportunity. Malaysia is the second largest oil producer in Southeast Asia behind Indonesia. Malaysia's reserve produce about 600,000 barrels of oil and around 5.5 billion cubic feet of gas daily. The oil and gas are currently being produced from all three regions involving Sabah, Sarawak and Peninsula. In Sabah region, there are 7 offshore blocks which under exploration PSC as for year 2017. production of oil and gas from Sabah region account for approximately 14% of oil and 5% of gas of the Malaysia's total production. Three sedimentary basins in Sabah are Sabah Basin, North-East Sabah Basin, and South-East Sabah Basin. It is assumed that Glamour Merah Fields has similar lithology with Samarang Field, where it has a long year producing oil and gas, about 35 years. Therefore, Glamour Merah Field has high opportunities to be produced in a long time. So next, for the general geology and regional geology. In regional geology, Glamour Merah area is in the offshore of Sabah Basin. The field lies in the West Labuan Paisley syncline and characterized by the major north-south groove Morris Fault, which is the major tectonic importance. Glamour Merah Regional Fault was interpreted marks the transition from both inbound and outbound belts of the shelf region. The location-wise is approximately 130 km from Kota Kinabalu and 43 km from Labuan. This field is in ridge and syncline province where the innermost structural belt basin ward of the Cocker Fault Thrust Belt. The belt stretching initiating from northeast of Brunei onshore and ending on the offshore at Kodat, Sarawak, marking the transference from the inbound and outbound belts of the ledge zone. The Labuan Paisley syncline is bounded to the north by the Maurice Padas Sekaran fault line. The characteristic of Glamour Merah is a prograding delta with coastal particulate deposited in the larger segment of Middle Miocene sands. During the latest Miocene to early Pliocene, towards the west and northwest, a series of deep-water submarine fans were deposited. The geological features of Glamour Merah Field are primarily made from anticline and syncline structures with a high possibility of fault the reservoir units. These unconformities are due to the Maurice fault plate shift, which causes change to the depositional environment from the deeper coastal section to the shallower section. The main tectonic elements of Sabah are a major fault thrust belt trending. The complex tectonic mechanism caused by the collision of the three major plates, which are Eurasian, Indo-Australian, and also the Philippine Sea Plate. In general geology, there are 5 tectonostratigraphic provinces in Sabah Basin. First is ophiolite complex, the second one is Rajang Crocker accretionary prism, the third one is broken formation and melanges, and fourth one is neogene sedimentary rocks, and the last one is Sempurna Sulu Up. In stratigraphic setting, the main elements of the Sabah or Sarawak framework are the Sunda Shale, the Rajang Group Fault Thrust Belt, the Oligocene-Miocene basins, the Miocene-Pliocene basins, the Northwest Sabah platform, the Luconia block, and the East Sabah ophiolite. Glamour Merah is situated on the inboard belt close to the outboard and barram belts. These are mostly Oligocene-Miocene plastic deposits, and the entire thickness of the sediment prism created by the inboard belt surpasses 12 kilometers. The Oligocene-Miocene basins are found on either side of the fault thrust belt, and the sediments that make up these basins are erosion products of the fault thrust belt's uplift. These belts runs roughly parallel to the fault thrust belt and stretches southward from offshore northwest Sabah to the onshore. The anticlines in the northern half of the inboard belt deviate to the north, east, and southeast.
Petroleum system is a core concept of petroleum geology, which is the study of oil and gas formation and explorations. These are the main key elements which encompass source rock, migration, reservoir rock, and seal or cap rock. Source rock, from the literature review, we found out that Gelama Merah field source rock was originated from the heterogeneous organic matter, which said to have been deposited and concentrated in the marine compact interval. Next is the migration. We assume it to migrate through the fine-grained source rock, which occurs in the up-dip direction movement. Next is the reservoir rock. So based on the core data report, it is identified that Gelama Merah's reservoir rock is mainly made of possible interbedded sandstone with formation of thin shale. Next is the traps. So traps in the Gelama Merah were created by the growth of faulting produced by the rollover anticline and anticline features due to naturality of the formation. Then we also found out that this is the most common structural trap in Sabah West. Last is the seal rock. So based on the core data report, it is identified that claystone presence within the formation act as the seal rock due to its characteristic which have low porosity and also low permeability. So move on to the well log correlations. So the well log correlation between these two wells, GM3 and GM4, were conducted to analyze the connection of equivalent patterns between this well in order to identify the lithology and the characteristic of the logs. So from the well log data and also correlate with our MDT and pressure plot, we found two possible interest zones in Gelama Merah field. We name it as Sand Unit 1 and Sand Unit 2. From the correlation of Gelama Merah 3 and Gelama Merah 4, it can be seen that Gelama Merah 4 is higher than Gelama Merah 3. However, we've been expected to get this since we assume that our system is an anticline features. The details of the interpretations of the wells and also formation evaluation will be explained later on in chapter 2 by my groupmate. The positional environment of reservoir sands were interpreted from the analysis of the shapes of gamma ray motifs. From our well log data, it can be seen that our case consists of mainly serrated or sawtooth shape due to irregular patterns or spike of the gamma ray log. So the grain size could be interbedded shales and sand, while the depositional environment could be fluvial floodplain with mixed tidal bar or debris flow and canyon fill. So the reservoir setting model is constructed to give a better understanding of the subsurface of the reservoir that can define the well placement, reservoir volumetric estimation, and also the production planning. These are the steps on how to develop the 3D structure of the reservoir system. Firstly, digitize the structure map by using web digitizer. This mainly to develop the structure of the surface map in 2D, 3D, and also skeleton grid. Once we have obtained our surface model, then we plot the coordinate of the GM3 and also GM4 well. After we have plotted the well, then the stratigraphic model can be developed by creating new well and importing all the well log data that are available. Next is property modeling. So in order to develop this model, some calculations are involved, such as V shale, density porosity, ND porosity, effective porosity, as well as water saturations. So as you can see in this picture, these are the example of the porosity upscaling. So it can be seen that the scale of the porosity of this field from higher to the lower, this depends on the colors that shows at the left side of the picture. And then after we have done the upscaling modeling, we can come up with the hydrocarbon volumetric assessment. So these are the gross rock volume result that we obtained from the calculation using ImageJ software as well as Excel sheet. The formula that we use in GRV calculations, which is GRV equals to gross interval in meter times with area in meter squared. We calculate our GRV in minimum, most likely, and maximum case. So for minimum case, GM3 gives a total approximate 140,000 acre-feet, while GM4 gives a total approximate 86,000 acre-feet. For most likely case, GM3 gives a total approximately 150,000 acre-feet, while GM4 gives a total approximate 96,000 acre-feet. For maximum case, GM3 gives around 170 acre-feet, 170,000 acre-feet, and GM4 gives around 105,000 acre-feet. Next is the original oil in place calculations. So the formula that we use to calculate the STOI is this formula, as you can see on the slide. So this time we also calculate for minimum, most likely, and maximum cases. The total STOI that we get from minimum case GM3 and GM4 is approximately 150 billion barrel. For most likely case, we get around 187 billion barrel, and maximum case we got around 228 billion barrels. Last but not least, from the geology and geophysical study is the uncertainties. So the first uncertainties is the unavailability of the seismic data. This can lead to difficult in estimating the presence of oil on the field and lead to inaccurate result on the determination of the actual reservoir boundary. Next is the non-relevance data from contour map. So from the contour map zone for our case study, it shows that the zone is between 1,300 meter depth to 1,500 meter depth. However, the zone of interest for our field started at around 900 meter depth. Last but not least is the unavailability of the well test report, reservoir analysis, and also core data report. This can lead to an anonymous and inconsistency in making decisions, since we have to refer to other case study report from previous study of Gelama Merah 1 and also Sidetrack 1.
Hi, welcome back. Now I would like to give a brief explanation regarding the flow of PetroPhysics. First of all, after producing the tech log by using tech log 64 2015, full log interpretation of GM3 and GM4 was conducted. Then pressure plot was plotted to find potential oil-water contact depth in the formation based on the MDT data given. After identifying the potential oil-water contact, PetroPhysics properties such as shale volume, porosity, and water saturation were calculated. These physical properties can be calculated by using the data given in the Excel from GM3 and GM4. The next activity is to calculate the cut-off analysis, which is need to calculate to find the net to gross value for the sand unit for both GM3 and GM4. The calculation will evaluate for three cases, which is minimum cases, most likely cases, and maximum cases. At the end of PetroPhysics section, three values were obtained which represent each of the cases.
Next, I will be explaining about PetroPhysics evaluation. PetroPhysics evaluation is one of the important departments in field development project. PetroPhysics evaluation data will help for reservoir and drilling engineering project, as the data will indicate the performance of formation and the potential to become a production for hydrocarbon in the future. Next, for PetroPhysics evaluation of the properties and the parameters of the PetroPhysics in Gelama Merah field, the determination of water resistivity was measured at clean water zone at depth of 1,480 meter to 1,670 meter of Gelama Merah field 3 at the sand unit 2. The relationship of porosity and resistivity are shown as the slope of 0.2605 from the picket plot method, from the tabulation of data from the determination of water resistivity. One of the most important aspects in petrophysical evaluation is formation evaluation. Formation evaluation is made by interpreting the log from the glomerular field. From the log interpretation, we can differentiate between the two zones, the non-hydrocarbon zone and hydrocarbon zone. The non-hydrocarbon zone is a zone of the formation that has no potential in containing hydrocarbon in the formation. Next, for the hydrocarbon zone determined based on the availability of the log shown. Determination of hydrocarbon zone is important to decide where is the location of the hydrocarbon and the possibility of production zone from the formation in the future. From the log interpretation, we can determine the location of the water-oil contact in the formation. Determination of water-oil contact location based on the plotting of the MDT data provided. The construction of the graph helps determine the difference in pressure in the formation system. The determination of water zone is important. Hence, the focusing on the hydrocarbon zone and where is the potential production in the formation can be determined. Next, for the log interpretation for glomerular field 3, sand unit 1, the presence of butterfly effect on the neutron and density porosity log showing presence of hydrocarbon in the formation. The GR log also indicate the formation contain sandstone. Sandstone have the potential to contain hydrocarbon in the formation fluid due to the porosity that can store formation fluid in the formation. For the log interpretation for sand unit 2 at glomerular field 3, the presence of butterfly effect also shown in the formation, also with the help of resistivity log showing high spike of resistivity indicating hydrocarbon, most likely oil due to small gap in the butterfly effect. Next, the shelly sandstone lithology of the formation showing the presence of sandstone allows the formation fluid stored in the pore. Also in the sand unit 2 of glomerular field 3 indicate the location of the water-oil contact in the formation. Next, for glomerular field 4 log interpretation at the sand unit 1 of glomerular field 4, there are also large volume of sandstone presence in the GR log indicate potential formation fluid containing hydrocarbon. Also, the ND log show butterfly effect also show potential hydrocarbon content despite resistivity from the resistivity log. Last but not least, for sand unit 2 at glomerular field 4, show same pattern as the sand unit 1 for glomerular field 4, showing high presence of volume in the sandstone and also presence of ND log showing butterfly effect indicate high potential for hydrocarbon content in the formation. That's all for me.
Now we will proceed to the visual calculation. Visual can be calculated using the formula given, which is GR log minus GR clean over GR shell minus GR clean. GR log can be obtained directly from the Excel or from the log, while the GR clean represent the minimum GR can be obtained by finding the lowest GR value in the sand unit, while the GR shell is the maximum value which can be obtained by finding the maximum value of GR in the sand unit. So after obtaining both GR min and GR max, we can calculate the visual, and after calculation was done, the data was recorded in the table. As we can see, for GM3 and GM4, the GR mean is quite high for GM3 while the GM4 is quite low. As for the GR max, the value for both GM3 and GM4 are quite similar. Now let's proceed to porosity calculation, which is by using the porosity density. Porosity density can be calculated by using the general formula, which is rho metric minus rho bulk over rho matrix minus rho fluid. However, since the formation is made of shelly sandstone, we have to calculate the porosity density using the corrected formula for shelly sand. Thus, the new formula is given below, which is rho metric minus rho log over rho matrix minus rho fluid minus V shell times porosity density shell. So as for the rho density of matrix, 2.65 has been chosen due to the formation is made of sandstone, while the rho fluid can be obtained directly from the Excel. Each well for GM3 and GM4 has different value, which is 1.1744 for GM3 and 1.162 for GM4. As for the rho bulk, we can directly obtain from the Excel. Now for the calculation of water saturation. Water saturation can be calculated by using three methods, which is Archie, Simandox and Waxman-Smith. Archie is used for clean sand, while the Simandox and Waxman-Smith is used for the shelly sand. Proceed to pressure plot from MDT data. Pressure plot for both GM3 and GM4 has been plotted using the MDT data given. As a result, oil gradient of 0.38 and a gas gradient of 0.433 was obtained. After plotting the hydrostatic line and oil gradient line, potential oil water contact of 1480 meter of TVDSS was obtained, and after that, the depth was correlated with the tap clock. Proceed to visual cutoff. Visual cutoff can be obtained by plotting the graph of hydrocarbon pore volume versus visual. Hydrocarbon pore volume is the product of volume and porosity and oil saturation. Volume can be directly obtained from the gross rock volume calculation in the G&G section, while the porosity is calculated in the previous slide, while the oil saturation can be obtained by subtracting 1 minus water saturation. As for the visual, also has been calculated in the previous slide. After plotting the graph of HPB versus visual cutoff is obtained by identifying when the graph is no longer increasing. As for the GM3 unit 1, the visual cutoff is 0.38. Now proceed to net to gross. After obtaining the visual cutoff and the porosity cutoff, we can proceed to the net to gross measurement. As an example, the net to gross can be calculated by first calculating the original interval, which is 184.79, and after applying porosity cutoff and visual cutoff, we can measure the interval left, which is we get 180.58 by dividing the total with the original interval, we get the net to gross, which is 0.855235. Last but not least, the summary data for GM3 and GM4. As I mentioned in the previous slide, which is during the flow of PetroPhysics, all the calculations were conducted for three cases, which is the minimum case and most likely cases and the maximum cases. So the calculation was repeated for several times in order to obtain the three cases for each sand unit. So as you can see in this slide, this is the summary data for Glamour Merah 3 for Unit 1 and Unit 2. The yellow one is the for Unit 1, while the orange is for the Unit 2. Okay, this slide represents the summary data of GM4, same as the previous slide, which is for the GM3, and the yellow one is the for Unit 1 and the orange one is for the Unit 2. Visual porosity and SW has been obtained by calculating the average value from the Excel after applying the porosity and visual cutoff. So I think that's all from us. Thank you for lending us your ear. If you have any inquiries, feel free to ask. Thank you.